Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering the Module 7 Inquiry 3 HSC question. This is from the 2019 paper, question 23, and it's on the photoelectric effect. Okay, a student investigated the photoelectric effect. The frequency of light incident on a metal surface was varied, and the corresponding maximum kinetic energy of the photoelectrons was measured. The following results were obtained. We have the frequency as 10 times the power of 14 hertz, and we have the maximum kinetic energy in electron volts. We'll scroll down. It says plot the results on the axis below and hence determine the work function of the metal in electron volts. Okay, so what we're trying to do here is make it accurate and have the correct units. We have a look, we are given the scales, we just need to plot it out. So let me zoom out a little bit, okay, just so I have the values, and I'm going to go about plotting these numbers onto this chart, and then we'll get a line and we can sort ourselves out from there. So stay tuned. Okay, so this is what we have. This is the plot that we have of the linear function between, or at least it looks linear, between the maximum kinetic energy and the frequency of the light that was shining onto our piece of metal. The next thing we need to do is construct a line of best fit, and we'll work our way down, draw a line of best fit through our dots, so midway through the points, and then we'll link it up to the maximum kinetic energy. What I might do here, just to cheat my way through, instead of trying to draw it out, I'll see if I can use some symbols, and I'll try and draw the line like so. So I assume this is sort of the best way to do a line of best fit, and you got to make sure you find the point that just looks like it's going halfway between all the dots, which I feel like this is a nice spot to be at, around about this point here. Okay, I'll just make the lines a little bit thicker so it's a little bit easier to see. Alright, so there's that. And then the next point is, so we've plotted the results in the axes, and then we need to work out the work function. Now there's 2 points I guess you need to look at. This point here, this 0 point, so when kinetic energy is 0, the frequency that you see is your threshold frequency. Okay, so there's that. If you look at this bit here, when your frequency, so when there's no light coming through, no light shining in between, when frequency is 0, that value that you have there, that is your work function value. So this is the energy required to displace an electron from a metal surface. So I'll just write that down. Okay, this value that we have here, it looks like it's on the point of 4. So we can say from our graph, the indicator would be, or from the line of best fit of our graph, the max or the work function is 4 electron volts. Don't be concerned by the negatives. These negatives, you can interpret the negatives as energy that's gone into the metal to push the electron out. So from the graph, the work function, and you can write work function as phi, is 4 electron volts. And that's how you do the question for this particular type of graphing and plotting. Please make sure you use all the relevant key data points on the graph. Use all the points, graph it correctly, make sure the units, the scale is correct, and make sure you practice your line of best fit. The line of best fit should be going through the dots, as you can see here. And so that's how you will do that. So 4 electron volts. Thank you for watching. Give this video a like if you thought it was helpful, and I'll see you next time.